grade 11 to grade 11, we have similar physical quantities can be added and subtracted. Mane, you can add length to length. You can add what do you call volume to volume. Okay, you cannot add length to liters. It's not possible. You cannot add mass to liters. It's not possible. So similar physical quantities can be added or subtracted. So what we are doing here also we are doing the same. See, voltage should be added with the voltage. This voltage should be equated to the voltage. So that is why we are taking the voltage equation of resistor, voltage equation of inductor, voltage equation of capacitor. So V is equal to Q by C. So we can add it now. The input voltage V is equal to what? IR plus L into di by dt divided, plus Q by C. Is that clear now?
Yes.
So these are all the voltages. Is that clear? Now, in the phasor diagram, see, this is what is my input signal? V is equal to Vm sin omega t. Okay, V is equal to Vm sin omega t. Whereas current is what? Current is I is equal to Im sin omega t plus phi. That phi we have to find out. What is that angle? Angle is the phi. Phi 1 money. Here it is in phase. Here it is leading or lagging. Current is lagging. Here current is leading. So that is why I cannot write now general. I cannot write in one equation key it is leading, lagging, and all. So that is why I wrote phi.
What is the direction of the current?
Direction of the current. Direction of the in AC. What will happen? That's why we don't say direction. Money how इसमें signal है ना?
Yes.
It's like it is oscillating, no? So we don't have a particular direction, one direction. Quarter cycle it is changing. How can you write the direction now? It's not possible. So that is why for AC we don't write the direction. For DC we can, for DC we write the direction. Okay. Now at last, so after doing the derivation, I'm just writing the final equation now. So I got here I is equal to what? Vm by I is equal to here I is equal to Vm divided by under root of I got here R square plus XC minus XL whole square. Okay, R square plus XC minus XL whole square. Is that clear now? XC minus XL whole square. So now, so here Im is equal to Vm by this value. What is XC? XC is what? Capacitive reactance. XL is what? Inductive reactance. Understood now? XC is capacitive reactance. Means again, the resistance also resistance. As we have equated the voltages, you have to equate again resistance with the resistance. Is that clear? See, you can compare. You cannot compare bio marks with mass marks. Okay, he is good at bio, so we will compare it with mass marks. It's not possible, right? It's not possible. You have to compare with the same subject to same subject, right? Yeah. Six. No. That's all. Better. That's all. Okay. So Im is equal to Vm by R square plus Xc minus XL. What is XC? XC is capacitive reactance and XL is inductive reactance. So that we are comparing all the reactants together. Why? Because we have to draw the phasor diagram and all. So when we draw the phasor diagram, it is like this. So in all the currents we are comparing now. To draw the phasor diagram, this is the current. Okay, current in the resistor. It's like this. This is current in the sorry. We are comparing the voltages. Here we are comparing the voltages. So this is VR resistor, this is capacitor, this is inductor. So finally, when we are using the additional property of the vectors, so we got the final equation like this. Okay, we got this is VC minus VC plus VL, and this is VR. Okay, so the resultant is how we have to draw this, complete the parallelogram, and we get the final voltage. Is that clear? Are you understanding? See, in दोनों को जब add करेंगे तो VC plus VL, only this is left because this is bigger than this. The addition property of the vectors. Then what we are doing? Then we are taking, these are the two vectors. I want to find out the resultant equation. Resultant equation के लिए complete the parallelogram and draw the diagonal. Then you get the final equation. So here this is omega. Okay, this is phi. This is phi. Okay, this is the angle. That angle is here. Got it now? ये जो angle phi है ना, ये angle यहाँ पे है. That means this is the input. This is the final resultant voltage, and this is the given voltage. That much is the angle. Is that clear? So that we are writing omega t plus phi. Now after that we have Im is equal to this. So this, instead of writing this, I am writing here implies I is equal to what? Im is equal to Vm by Z. Okay. Z is equal to impedance. Z is known as impedance. So why do we write Z instead of writing resistance? We could have written resistance over there because this resistance is connected to the cycle. This resistance is connected to AC cycle. So whenever AC components come into picture, instead of writing resistance, we write impedance. Is that clear? We write impedance. See now, क्या बोलेंगे उसको? Suppose a person, example, a person like in we have NCC. NCC means cadets. Okay. So अगर suppose वो बंदा अगर वो dress पहन के माने uniform पहन के he is going. We don't say like he is going. He is a cadet now. Understood now? Now suppose the same person is wearing the apron and working in the hospital. We say doctor or a lab assistant or something like that. So the name has changed now. Understood? The same person. But when he's outside, when he's not with the uniform, we just call with his name. But when he's at the station, we say, yeah, when I'm in the school, they say teacher. And I'm outside, they call with the name. Okay. Understood? So that is the impedance. Okay. So impedance is Z. It is also measured in ohms now. Okay. So now what is the angle here? Tan phi. That is how much is the final angle? Tan phi is equal to what? VCM minus VCM minus VLM divided by VR, RM. Okay, there's a resistance. Okay, voltage across the capacitor minus voltage across the inductor divided by VRM. That is the phase angle or the final phase. Okay, that means what is that angle? The resultant voltage is making an angle phi with the initial voltage. The resultant voltage is making an angle phi with the initial voltage. Once I have initial voltage, VR is the initial voltage. V is the final voltage. So that is that much angle it is making. How did we calculate? With the angle phi. So tan phi is equal to opposite side by adjacent side. Where is opposite side? This is opposite side. BC minus BL. Opposite side, and this is the adjacent side. Is that clear? Opposite by adjacent, we got tan phi. Is that clear? So this is the final equation of current. This is the final equation of tan phi. The same equation we are going to derive using the analytical solution. ये तो phasor diagram है. हमने phasor diagram use किया and we did it. But there is one more solution called analytical solution. In analytical solution, we take the equations now. Vm is equal to VR Im sin omega t like that. We start with the like mathematical solution. Okay? But at the end again we'll come back to the same. Is that clear? At the end we come back again to the same equation. Means the same thing is proved using analytical solution. Okay? So now what will happen here if suppose if XC at the result if XC is greater than XL, what will happen? What is the circuit called? It is a capacity circuit. Means this capacitance reactance is leading the inductive reactance. What happened? Right, just take the tissue, clean that. Yeah. Clean. Take the tissue. Sometimes because of the light also it happens. Yeah. So XC minus XL. So here XC, that is capacity reactance is leading the capacitance is leading the inductance. Okay. So that is known as capacity circuit. Agar suppose XC is less than XL, what will happen? This is said to be inductive circuit. इसको बोलेंगे capacity circuit, इसको बोलेंगे inductive circuit. If both are equal, what will happen? Both are equal. What will happen? It is said to be resonance circuit. ठीक है? अगर XC ज्यादा है XL से, then we say capacity circuit. If XC is less than XL, inductive circuit. If XC equal to XL, then we say it is a resonance circuit. The circuit is in resonance now. Understood? Okay? So, yeah, this is capacitive. Right. This is the capacitive circuit. Capacitive circuit. I'm writing CKT. Okay, circuit. This is inductive circuit. And this is resonance circuit. Okay. This is said to be resonance. Okay, the system is in resonance. The whole circuit is in resonance. Resonance कब होता है? Simple example I will give. Like suppose we used to have suppose have you seen in the radio in the car? पहले olden days में we used to have a proper radio. There is two knobs like this. One big knob and one is a small knob. एक वाला station का है, एक वाला tuner है. इसको tuner बोलते हैं. This is the one which is for station. This is for the tuner. Channel station, tuner station. When we are rotating this, अभी तो channels we can fix it. 1, 2, 3, 4, 5, 6. हम fix कर सकते हैं. पहले वाला fix नहीं था ऐसा. So first you just like move the knob, then it starts moving on the stations, frequency stations. Now I have 88.8 megahertz. I don't know. There is some radio FM something. 88.8 है, 89.1 है. Then I have 100 point something, 100.6 something like that. There are so many stations. Generally, that also I will tell you. The stations are only from 88 megahertz to 108 megahertz. This is for every country. This you should know, 108 megahertz. This was in communication, but that chapter is deleted. So that is why all our stations, radio stations, are only between 88 to 108. Yeah, 88.8, 89.1, 100, 100.6, then 102, then 106 last finish. और है लेकिन these are the famous channels. हाँ 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 हो जाती है. Now 88 megahertz to 108 megahertz. Is that clear now? So now what will happen? अगर हम लोग 88.8 से 89.1, what happens? We'll get some buzzing sound. The buzzing sound means what is happening? वो 88.8. So what is happening is the frequency of the incoming signal, which is coming from the radio station, and the frequency of your circuit. If it matches, then resonance will take place. When a resonance takes place, then what happens? You can hear the song, listen to the song.
So actually the car has an antenna.
Car is having an antenna, but you cannot see that antenna, small one.
No, so nowadays,
पहले वो long
cars
वाला,
had
the long antenna, but now it is very small antenna.
No,
It is there in cars.
It is there everywhere. In every car, it is there.
Yeah, inside is there.
Even in our mobile phone, there is an antenna. You know that?
Yeah.
The size of the antenna is this much. Because they have increased the frequency of the mobile phone now. जो frequency है ना, पहले kilohertz में था, megahertz में था. Now it is in gigahertz, terahertz में. No, when they increase the frequency, automatically the length of the antenna reduced drastically. अभी सेंटीमीटर से वो मिलीमीटर में आ गया. इतना 1 मिलीमीटर है उसका एंटीना. उसको बोलते हैं पीएफ. जो फोन में है ना, उसको पीएफ बोलते हैं उसको. That is the name of the antenna. Okay, so what will happen? Buzzing sound is coming. Means when you are crossing one station to another station, what happened? The incoming frequency and frequency of the radio is not matching. When they match, then what will happen? Resonance will take place. When resonance takes place, we'll be able to listen to the sound. Is that clear? So that is how we'll find out the frequency, capacitive frequency, inductive and resistive. So what will happen? The tuner hai na, ye wala chota wala, that is a capacitive actually. That actually we were unable, in the olden days, people were not able to match the frequencies. So once they come to the station, they change this capacitive circuit to bring it equal to this is fixed value, but they change this one to make it equal. So then we'll be able to listen to the sound. That is how it is used. Okay, so I'll stop the class here for today. So actually I was supposed to complete the analytical solution. Tomorrow I will do it again. Okay. How?
Thank you so